So if I talk about IP is called Internet Protocol. After IP addresses, I will also tell you about MAC address. Okay. So IP is used to identify any endpoint in the network uniquely. It is a logical identification of endpoints. It can be changed manually, or we can use DHCP, Dynamic Host Configuration Protocol, to assign IP addresses automatically on the endpoint. Layer 3 devices understand IP addresses, right? Layer 3 devices will receive and forward the traffic based on IP addresses. Now, if I talk about the types of IP addresses that we can use in the network, we have two versions, okay, or you can say two types. We use two versions of IP addresses. First of all, we have IPv4 addresses, version 4, and IPv6 addresses. Okay, so we will start with IPv4 addresses, and after doing some of the practicals over IPv4 addresses, then we will start using IPv6 also. Okay, so if I talk about IP addresses or IPv4 addresses, then we can say IPv4 addresses are used. See, it is same. It is at the end an IP address, so it will be used to identify the endpoint, right? But IPv4 addresses are represented in 32-bit words. An IP address contains 4 octets, and every octet has 8 bits, right? So overall it is 32 bits. Every octet has 8 bits. It is defined in dotted decimal format. It is defined in dotted decimal format. Let's say if you want to configure an IP address, you can configure an IP address like this. You have to use 4 octets like this, 1, 2, 3, 4. And there will be some bits used in these octets, some bits available in these octets. According to these bits, you can identify the network addresses, IP addresses, broadcast addresses, okay? Here we also use a term called the subnet mask, which will be used to identify the network bits and host bits of a network address. We will discuss about subnet mask and the subnetting also. Okay. Now these IPv4 addresses are classified, are divided into 5 classes. Okay. First of all, we have class A, class B, C, D, and E. Class A starts from 0.0.0 to 126.255.255.255. 0.0.0 is considered as no IP address, okay, or any IP. 0.0.0 means no IP address or any. Class B will start from 128.0.0 to 191.255.255.255. Class C network addresses will start with 192.0.0.0 up to 223.255.255.255. Then we have class D addresses 224.0.0.0 to 239.255.255.255. Okay. Then 240.0.0.0.0 to 255.255.255.255. This is your IPv4 address space, overall IPv4 address space, which can be used, okay, in which this dot 0.0.0 and 255.255.255.255, these two addresses are unusable, okay. It is called no IP address or any IP address, and it is called broadcast address, okay. Layer 3 broadcast address. Okay, IP works at layer 3, right? IP is a layer 3 protocol, network layer protocol. So if anyone is asking about layer 3 broadcast address, then you can tell this network address, this address as the broadcast address. Okay, 255, 255, 255, 255. Clear. Other than these ranges, here we have a separate range called loopback address range. Okay, it will start from 127.0.0.02 127.255.255.255. It is used for local connectivity. Let's say you want to verify the connectivity with your NIC, whether it is working fine or not. You can ping this IP address. Okay. If I talk about local time clock server IP address, it is 127.127.1.1. These addresses are used for local testing. Okay. This is called loopback address range. If I talk about other range, we have one more range called APIPA. APIPA is called automatically provided IP addresses. Now, who is the responsible authority to allocate IP addresses in the network, to provide IP addresses in the network?
The network engineer, right?
Yeah, but you will purchase the IP addresses
Oh,
from
okay. Okay.
INA.
I
Globally, it will manage IP address space, right?
right.
Internet Assigned Number Authorities. INA will not only manage IP addresses, it will also manage AS number, autonomous system numbers.
Okay.
Like in BGP, we use public AS numbers, right? Autonomous system numbers. So these AS numbers are also allocated by INA. Okay. Nowadays, if I talk about this IPv4 address space, it is fully exhausted. All the IP addresses are, you can say, sold to ISP. Now, when you are going to purchase any public IP address, ISP can provide you public IP address. But if I talk about the IPv4 address space, which belonged to INA, now it is exhausted. Okay, all the IP addresses are sold because you know that every candidate, everyone in the world is having more than 3 devices nowadays, right? And they require IP address. So most of the all the IPv4 address space is exhausted now, and we have started using IPv6 addresses also in the WAN. Okay, in WAN you will see IP addresses or IPv6 addresses are being used. Now, if I talk about this APIPA range, automatically provided IP address. It is used when any client is configured to get the IP address from DHCP server and it is not able to get the IP address from DHCP server. Okay. Client will assign an APIPA range IP address on its own automatically. So the IP address range is 169.254.0.02, 169.254.255.255. This is a pipa range. Okay. So when you configure any endpoint to get the IP address from DHCP server and the client is not able to get the IP address from DHCP server for any reason, then client will assign an IP address on its own, which is called a pipa range IP. Now, in our LAN and WAN, we can use only class A, class B, and class C IP addresses in LAN and WAN. Class D IP addresses are reserved for multicasting, multicast IP address. These are called multicast IP address. Let's say if there is any multicast protocol available like EIGRP or OSPF, they have some multicast IP addresses assigned already. So this is, you can say it is reserved for multicasting. Okay. Like EIGRP uses 224.0010. OSPF uses 224.005 and 6. RIP uses 224.009. VRRP, HSRP, these protocols will also use a multicast IP address. Okay. Then class C is reserved for experiments and researches. Okay, so we don't use class D and class E IP addresses to configure on the endpoints. configure on the network device. Okay, we use A, B, and C classes. Now we have two types of private IPv4 addresses to configure in LAN or WAN. Okay, LAN or WAN. First of all, we have private IPv4 addresses defined in RFC 1918. You can read this RFC if you want. Okay, and public IPv4 addresses. So these private IPv4 addresses are used in LAN. They are free of cost. We can configure them on our internal network devices to get network connectivity. Okay. These addresses are not routable on the internet. Now, first of all, tell me why this categorization is there. Why we need to categorize private IPv4 and public IPv4 separately. Can anyone tell me? See, if you are not categorizing these address in different, you can say different type of addresses like private IPv4 and public IPv4, then anyone can use any address in their network, right? Then globally address conflict can occur, or you can say duplicacy of address can occur. So to prevent, or if you want to say, let's say you said that I will not you say that we will not assign the IP addresses randomly. We will sell all the addresses. So this IPv4 address space was depleted very earlier, right? Very soon. So this address categorization was there that you can use private IP addresses in your LAN free of cost to maintain network connectivity within your internal network. But when you are going to access any resource over the internet, over the public network, then you have to use a public IP address. There you cannot send the traffic using your private IP address, okay? Because private IPv4 addresses are not routable on the internet, okay? So this is how we are trying to save this address space, okay? Now, if I talk about public addresses, public IPv4 addresses are purchased from ISP to communicate with internet, okay, or to send the traffic over the internet, okay. So if I talk about the range of private IP address, see, these public IP addresses are not free of cost. You have to purchase them. You have to give rent of your public IP address yearly, okay. Now if I talk about range of private IP address, see, I told you that you can use ABC classes only. So private IP address range belongs to ABC class only. For class A, class B, and class C. Class A range is 10.0.0.0 to 10.255.255.255. Okay. Class B address range 172.16.0.0 to 172.31.255.255. Class B address range is 192.168.0.0 to 192.168.255.255. These are the private IPv4 address range. Other than these addresses, all the IP addresses are public IP addresses. Okay. If you are writing this address 1.1.1, it is also a public IP, right? If you are writing an address 11.1.1, it is also a public IP. If you are writing an address 10.1.1, it is a private IP address. Okay. It is like this. If your IP address lies in these ranges, then it is a private IP. So whenever you are going to create a LAN network, you will use these IP address range to configure IP addresses on the host connected in your LAN. And when you are going to communicate with internet with ISP, then you are going to use public IP network. Let's say if I want to show you, I can create a small network like we created here. Okay, so in this LAN, if I want to use multiple segments, then I can use private IP networks like this 10.1.1.0, 10.1.2.0/24, right? 10.1.3.0. If I have different segments, different departments in the network, then I can use different network IP addresses. Otherwise, if I am not using, you can say I'm not creating different segments. Like if you have different department like HR, sales, or you have finance department, admin, IT, and you want to use different network IP address on each and every segment so that you can uniquely identify their users traffic on your uplink devices like firewalls. You can create more granular policies with the help of different subnets, right? You can define policies as per the segment, as per the department. Okay. Like if you don't want to allow Facebook for HR users and sales users, you don't want to allow entertainment websites, you don't want to allow content. Let's say you don't want to allow any user to upload PDF files, .doc files to any server, then you can identify them with their network address uniquely, right? So you can use unique or different network addresses within a same network if you want to create more granular policies on your firewall. And these are all private IP network connected or configured in your LAN. When it comes to WAN connection, okay, here we use public IP subnet like this. Public IP subnet. Okay, behind this ISP, many public servers can be connected, right? Or any public user can be connected. They will all have public IP subnets, public IPs, or they will send the traffic using their public IPs. Now, you can ask one thing that in our LAN we are using private IP addresses, in WAN we are using public IP addresses. So how internal users will be able to communicate with ISP, right? So at that time, these private IP addresses will be translated into public IP addresses. That is the part of NAT and PAT, network address translation and port address translation. So we will discuss about it, okay? When you want to provide internet connectivity in your internal network where private IP addresses are configured, then which type of NAT you need to use. If you want to host any internal server for public users, then which type of NAT you are going to use. We will discuss about these real-time scenarios also. Okay. Any doubt in this private IPv4 address range or public IPv4 addresses? Okay. So these are the most commonly used classes in LAN. You will find the network address in your LAN network. You will find the network addresses from these classes. Now, when it comes to the IP addressing, you need to understand that how many hosts or how many addresses we can calculate from these classes, right? If I talk about class A, class B, class C, we have some predefined or by default subnet mask. Now let me tell you about the subnet mask. What is subnet mask?